The U.S. Navy's initiative to redevelop and field a sea-launched nuclear cruise missile marks one of the most significant shifts in American strategic defense policy in recent decades. This program, known as the Sea-Launched Cruise Missile Nuclear (SLCM-N), is intended to restore a critical capability that was retired more than a decade ago, filling a gap in the U.S. nuclear deterrence posture and enhancing strategic flexibility for decision-makers. Historically, the U.S. maintained a nuclear-armed cruise missile launched from submarines known as the Tomahawk Land Attack Missile Nuclear (SLCM-N). That system provided a survivable, stealthy, and precise nuclear option at sea, with a range exceeding 2,000 kilometers. However, it was retired in 2013 due to shifting strategic priorities, arms control considerations, and the perceived sufficiency of other nuclear delivery platforms. The retirement left the U.S. without a low-yield, regional nuclear strike option deployed on attack submarines, a gap that the SLCM-N program seeks to address. The Navy's current plan envisions the deployment of the SLCM-N on Virginia-class attack submarines, which are among the most capable and advanced submarines in the fleet. The Virginia-class submarines feature modular payload capabilities, particularly the Virginia Payload Module (VPM), which significantly expands the number of payload tubes available for various weapons and systems. The SLCM-N is being designed to fit within these tubes and the standard torpedo tubes, facilitating integration without extensive redesign of the submarine class itself. The missile development effort is being led by 5 contractors: Leidos, Raytheon, Lockheed Martin, Northrop Grumman, and Florida Turbine Technologies, a subsidiary of Kratos. Each company brings specialized expertise in missile design, propulsion, guidance systems, and digital engineering. Their collective work aims to accelerate the missile's development through an approach emphasizing proven technologies, modular design, and digital integration to minimize risk and development time. From a technical perspective, the SLCM-N is anticipated to feature a modular all-up-round design where the missile body, booster, and canister are combined into a single unit. This configuration simplifies logistics and submarine handling by enabling the missile to be treated as a sealed package from manufacturing through launch. The propulsion system is likely to consist of a solid rocket booster used for the missile's initial launch from the submarine tube, followed by a turbofan engine that sustains the missile's flight during the cruise phase. This propulsion system mirrors the technology employed by conventional Tomahawk missiles and offers a proven balance of speed, range, and fuel efficiency. The expected range of the missile is roughly 2,000 to 2,500 kilometers. This range allows the missile to strike targets deep inland while the submarine remains well outside the reach of many enemy defenses, thus enhancing the survivability of the platform and the overall deterrent effect. The missile's guidance system is anticipated to incorporate a layered approach for precision and resilience. It will use inertial navigation systems (INS) for continuous position tracking, terrain contour matching (TERCOM) to compare onboard maps with the terrain below, digital scene matching area correlation (DSMAC) for visual navigation updates, and GPS for periodic corrections. This multifaceted guidance ensures that the missile can navigate complex environments accurately and resist jamming or spoofing attempts. Survivability of the missile during flight is a critical design consideration, especially as adversary air defenses become increasingly sophisticated. The SLCM-N program is expected to integrate Advanced Electronic Countermeasures (ECCM) to defeat enemy jamming in electronic warfare systems. Additionally, stealthy flight profiles that reduce radar and infrared signatures may be employed to evade detection. These features collectively increase the likelihood that the missile can reach its target in contested environments, ensuring the credibility of the deterrent. One of the primary challenges with the SLCM-N program is the integration of nuclear weapons onto platforms originally designed for conventional missions. Virginia-class submarines were built for a wide range of undersea operations including anti-submarine warfare, intelligence gathering, and conventional strike. Introducing a nuclear strike mission demands stringent new procedures for nuclear weapons custody, handling, security, training, and mission planning. The Navy is expanding its workforce training pipelines and updating operational doctrines to ensure that submariners are fully prepared to operate in this dual-role capacity. Additionally, infrastructure at naval bases and maintenance facilities will be adjusted to safely accommodate nuclear payloads. The nuclear warhead chosen for the SLCM-N is the W-84, which is also slated for use on the Air Force's Long Range Standoff (LRSO) missile program. This warhead is a modernized variant of the original W-80 design and offers selectable yield options ranging from low yield settings around 5 kilotons up to approximately 150 kilotons. This flexibility allows for calibrated response options, enabling strategic planners to tailor the deterrent effect to the specific threat or scenario. The low yield capability is particularly significant, as it provides a more usable nuclear option that can serve as a credible deterrent against limited nuclear aggression without immediately escalating to large-scale strategic strikes. The overall objective of the SLCM-N program is to enhance the United States nuclear triad, which consists of land-based intercontinental ballistic missiles (ICBMs), strategic bombers, and submarine-launched ballistic missiles (SLBMs). By adding a nuclear-armed cruise missile launched from attack submarines, the triad gains an additional layer of survivability and operational flexibility. Attack submarines are inherently stealthy and mobile, making them difficult to detect and target. This mobility complicates adversary planning and strengthens deterrence by ensuring a credible second strike capability. The strategic rationale for reintroducing the SLCM-N also relates to the evolving global security environment. Potential adversaries are developing increasingly capable regional nuclear forces and anti-access, area denial (A2AD) systems designed to counter U.S. forces. A sea-launched nuclear cruise missile provides a survivable, flexible option that can penetrate contested regions and deter adversaries from considering limited nuclear aggression. It expands presidential options in crisis scenarios, offering a response capability that is less escalatory than strategic ballistic missiles but more credible than purely conventional strikes. Despite the program's clear strategic benefits, it also presents challenges and trade-offs. Critics highlight that equipping Virginia-class submarines with nuclear cruise missiles may reduce the number of conventional strike weapons available on these platforms, potentially limiting their non-nuclear operational flexibility. Additionally, integrating nuclear weapons brings complex security, maintenance, and operational demands. The program will require sustained funding, workforce expansion, and continued technical development to meet its goals on schedule. The estimated timeline for initial operational capability of the SLCM-N is the mid-2030s. Achieving this milestone involves overcoming technical hurdles related to missile design, guidance, propulsion, warhead integration, and submarine modifications. The Navy and its partners are leveraging existing missile technology, digital engineering practices, and a modular design philosophy to manage these challenges and maintain development momentum. The SLCM-N program represents a deliberate and carefully planned effort to restore a critical nuclear deterrent capability that enhances the United States' ability to deter regional aggression and maintain strategic stability. By deploying a flexible, survivable, and technologically advanced sea-launched nuclear cruise missile, the U.S. strengthens its deterrent posture and ensures that it retains a broad range of options to respond to evolving threats. The program aligns with broader national defense priorities emphasizing resilience, flexibility, and credible deterrence in an increasingly complex global security environment.